Okay. Hey, everyone awake? Sorry about that, guys. I think the people back in Redmond heard me. So other people who aren't using it for production, what are the kind of main reasons that people have been waiting before they put their data up in the cloud? Yes? Security. Anyone else have another reason? Yes? Management? Okay. Anything else? Okay. Well, it turns out that security habitually comes out as the top or the number 2 reason why customers don't put their data up in the cloud. Okay. And the reason is this, right? I mean, if you look at this picture right now, what you're used to is the picture on the left, which is you install it on your machine, it's on your desktop, inside your CorpNet, behind some application servers. It's all good, right? You have full control over it. And then what Azure SQL DB is that it's the thing on the right, okay? It's basically a really easy way to explain this is that SQL Server is probably something that you can install and run on your laptop, and Azure SQL DB is probably something that you probably don't want to install on your laptop or try to run, or if you can. And this will try and give you an idea of the scale difference between the two. Just from a security perspective, Azure SQL DB handles roughly about 1.5 million authentications per day per data center. Okay, so if you think about just in the U.S. alone, where we have, I think it's getting close to 9 to 12 data centers. I don't have exact details. We're talking an awful lot of authentications, right? And this is massively, it's basically all the traffic from all the customers who come through the U.S. And so to kind of state this kind of succinctly, Azure SQL DB is an internet-facing, multi-tenanted, massively distributed public service. Now, what part of that statement actually kind of jumps out at you and makes you concerned? Public, multi-tenanted. And internet-facing is one of the big things that actually concern us because, most people don't put SQL Server on the web directly, right? I mean, if you do, you can, but no, most people don't because they hide it behind some kind of web server or application server. But SQL DB by itself is a web service, right? Which is why it's put directly on the internet, which means that it's open up to everyone. Okay, everyone sees IP addresses. Everyone can actually go and try to connect to it. Everyone can see the ports, everything else. Okay, and so that's typically a major concern. And as I go through this talk, you'll see kind of the things that we did to shore up the security in SQL Azure, kind of step forward in terms of trying to protect against that network threat. So the first thing I want to talk about is protection against network threats. Oh, and by the way, please feel free to jump in and ask any questions if you want. This talk is actually not going to be that long. It's fairly short. I'm counting on having some questions. And if we have time at the end, I'll just go through a really, really simple demo of actually just going through and creating a new database, and you'll see the firewall and everything else take place. So feel free to jump in. But when you think about network protection, what's the first thing people normally think about? And it's usually encryption, right? They usually think about channel encryption. And so this is no real big surprise. I mean, SQL Server has supported SSL encryption since, the 2000 days, right? And, for a web service, this is almost a necessity. If you don't have encryption, then you basically don't do business on the web. And so the TLS encryption is always enabled. Okay? This is a big difference between what SQL Server does and what we do on the cloud. In SQL Server, you have the option of turning it on or you turn it off. And actually, even if you turn off encryption in SQL Server, we do SSL negotiation because we always encrypt the login packet at the very least. So there's that one packet that potentially contains your credentials, and we make sure that's encrypted. But afterwards, it's your choice. And a lot of customers, a lot of times they do not actually put encryption on, and that's because it actually, can degrade performance, and they feel protected within their own intranet, and so they don't bother turning on the encryption. Their choice, but that's not a luxury that we have with SQL Azure. Okay, so the server will always enforce encryption to be enabled. And what this means is that even if the client doesn't say that I want encryption, the server is going to force it to use encryption. Okay? All the clients that we support connecting to Azure SQL DB support encryption at this point. The only ones that didn't were the really old ones that aren't supported with Azure SQL DB. So at this point right now, there should be no clients that connect to Azure SQL DB, they can't participate in this TLS handshake and TLS channel encryption. Another big distinction is the fact that we don't use self-signed certs. Right? Does anyone know why a self-signed cert is potentially harmful? I'm sorry? The gentleman up front says worthless. It's not quite, well, it depends, I guess, but it does have some concerns around a self-signed cert. Self-signed cert is basically a cert that doesn't have a root authority. You yourself are the root authority. I say that I generate the cert and I vouch for it. So it makes it very hard for another party to say that, hey, you're right, you vouch for your own cert, so therefore I trust it. Right? It kind of makes sense. Well, what SQL Server used to do is that if a lot of people didn't install a proper cert, they didn't buy cert and install it on the machine store, and when SQL Server started up and tried to actually go and find a cert and couldn't find one, it's like, oh, if I don't have a cert, I can't do SSL, so why don't I just generate one? It generated its own cert and used it to actually do the SSL handshake, which, it's better than nothing, but it's definitely not as good as having a real cert that you bought that has a proper signing authority. Okay. And one of the consequences of using a self-signed cert was that you can't actually validate it, right? Like I said before, the client has no way of actually saying that. Sounds like a train going through the. There's no way for the client to actually go and validate the fact that this cert is actually legitimate. It can come from anyone because, if I'm a bad guy and I give you my own cert, of course I'm going to say, yes, this is legitimate, please trust me, right? And so that makes it very, very difficult to do. But the problem is that because, like I said, a lot of the customers didn't have a cert and they actually relied upon a self-signed cert on the SQL Server days, that they, if they try to request encryption on the client side, because what that does is that it tells the client, hey, I want encryption. I'm explicitly saying I want encryption. Therefore, you should validate to make sure that cert is legitimate. Okay? If I don't ask for encryption and I do encryption, then I don't really care, obviously, that the cert comes from where because I didn't ask for it. But if I ask for it, then I want to know that this cert is legitimate. And the problem is that if it's a self-signed cert, I can't tell it's legitimate. And so we added this other keyword called trust server certificate. And what that meant was that even if I force encryption, if I get a certificate that I can't validate, then let it go and just continue. Okay. And so what does this do? Well, it opens myself up to what's called a man-in-the-middle attack. And I'm sure you guys here all probably know what a man-in-the-middle is, but just for the odd chance you don't, it basically is, it's an attacker who inserts himself between you and your server, okay, and pretends to be the server. So typically what they'll do is that, in a bad case, they'll eavesdrop. They'll do the communication with you, then they'll take your communication and relay it back to the server. And in between, it's just kind of listening to everything that happens. They're eavesdropping. In the worst case, they're actually modifying data, right? So they're actually, making changes that you don't know about. And this is one of the reasons that SSL is very helpful, because if you can actually use SSL to encrypt the channel so people can't listen, and furthermore, you know that the encryption is set up with a party that you know is actually valid, then you have a fairly high confidence that you're not being attacked by a man-in-the-middle. And I just put a little bit of animation here. It's nothing really fancy, but when you first make a connection to SQL Server or SQL Azure, or if there's a man-in-the-middle pretending to be one of those, then one of the first things we do is that we do the SSL handshake. And as part of the SSL handshake, the server is going to return you the public part of a certificate, right? And so it sends a certificate back. And then what happens is that if we are able to actually go and validate that the certificate is not where it should be. So here in the analysis case, it says the certificate doesn't look right. I'm checking it. It doesn't look like it's coming from the person that I expected it to come from. And so the client will disconnect. Okay, very, 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 very useful thing. And so you should always try to turn on client-side encryption, even if the server is already saying that you must encrypt. There is value in making sure that the client turns it on itself as well. And don't set the trust server certificate equals true. By default, it's false. Okay, so if you don't put anything in there, then by default, the client will actually not trust the server certificate if you force encryption. But if you can actually explicitly just say that trust server certificate was false if you want to be And here are some connection strings examples. There's there's lots of examples. I just discovered this morning in the Azure management portal that they actually give you this list. So they made it dead simple for customers. But as you can see for ADO.NET, ODBC, PHP, that the keywords are all the same. Okay, you can put encrypt equals true, trust certificate, service certificate equals false. I believe true and yes are interchangeable in most cases, and false and no are interchangeable in most cases as well. So you can use either or. Okay, but the key thing here is that the client should actually put encrypt equals true. The trust service certificate equals false is optional, but if you want to be extremely sure about this, then I would put it in there anyways. Okay, it does no harm, and it also catches the fact that if someone does change this, then you'll have two keywords and they'll throw an error. So that's about SSL encryption. Any questions on that? All right. The next thing I want to talk about is a database firewall. Okay, this is something that's specific to Azure SQL DB. SQL Server doesn't have this. And one of the things about Azure SQL database is that, if you're used to SQL Server, you know that you have the choice of many different protocols. You can do TCP/IP, name pipes, shared memory, VIA. You can do all sorts of things, right? But Azure SQL DB only accepts TCP/IP, and only in 1433. Now, that's significant, okay? And the reason that's significant is that in the SQL Server case, because you have named instances and because even the default instance, you can actually make it listen to a different port, what would happen is that, if the client didn't know what that port was, it would have to go and contact the SQL browser service. You guys are all familiar with the SQL browser service? Some of you? Do you guys know why it's not the best thing in the world? Yeah? Yeah, maybe? Well, sorry? Yes, people can see it from everywhere. SQL Browser is an unauthenticated UDP service. Okay, so it means that basically it will take a request from anyone and respond to anybody that wants it. And if you guys have been around for a while, you guys know that probably about a decade or so ago there was a whole thing with SQL Slammer. Well, that was directly tied to the SQL browser process. Okay, so since then, we've made fixes to the browser, but at the same time, it's a much more secure scenario to actually just shut off the browser service so that people can't actually reach that endpoint. So we only have 1433 in Azure SQL DB. No browser necessary. You know exactly what port you're going to go to. We only need to open that one port for connections inbound. Okay, and the database firewall is basically an IP filter based on the client address. So it means that I can basically limit either a particular IP address from which a client's allowed to connect, or I can give it a range. Okay, so it's up to you. Obviously, the more narrow you have it, the better. And the other thing you have to keep in mind also is that when you actually connect to SQL Azure, especially if you're coming from a CorpNet, you're probably behind a NAT. You've got network address translation. So the address you see internally is not going to be the same address that comes out externally. So you have to find out what your external address is and then add that to the firewall rules. And if I have time, I'll show you a bit later on. And one other thing is that I'm sure everyone here, if you play with SQL Azure, have hit this before. You create your server, you think that, hey, this is great, let me go and connect, open up SSMS, and let me connect to it, and you get a protocol timeout error. You get that TCP error code 0. And the reason is that by default, the database firewall blocks all IP addresses coming inbound. Okay, so the very first thing you have to do after you create your service is to go and add a rule to your firewall to say that let me connect in, or else it's not going to accept any TDS connections. Okay, and this is sort of a security feature. I know it got me. How many other people hit that problem as well? Yeah, probably. I don't know anyone who hasn't really hit this before, but so the diagram next to here, which is a diagram I took off from the online documentation, basically really quickly describes how the firewall works. And so we have rules based at the database level and at the server level. So if I set a rule at the server level, it means that anything that fits within these IP addresses that I've specified can come in and connect to any database in my server. Whereas I could also do it more granularly at the particular database. Like, for example, I may have one database that's only used by a particular set of applications, and so I can set the firewall rule for that one application so that those clients can connect to that database, but they can't access the other databases as well. a really, really nice feature for kind of partitioning out your surface area and security exposure. When traffic comes in through the internet or from within another Windows Azure service, one of the first things we do is we evaluate the firewall rules. And so we'll check to see whether, does this IP address, is it allowed by the server firewall rules? If the answer is yes, then we just let you go through. Of course, you do the authentication, authorization, all that stuff. But if the server firewall blocks your connection, then we go through and say that, okay, for the database that they're trying to connect to, do they have a rule there that lets this guy through? And if the answer is yes, then everything continues as normal. If no, we drop the connection. Okay, it's very, very straightforward. And the other thing is that, obviously this is a static IP list, and so if you're using a dynamic IP, then you have to account for the fact that your IP may change once in a while when your lease runs out. Yes, please.
You may be getting this in the next slide. You brought that up. I'm aware, for example, my Windows Azure services, they're not guaranteed IP, so you can't do IP-based firewall rules. So you have that option to enable Azure services for connection as just a blanket allow. Is there any additional checking done at the subscription level or anything? Or have I just violated my firewall rule essentially for everything in all the Azure data?
Yeah, so the question is whether for Azure services, right now there's a rule that allows all Azure services connect or none, if there's more granularity in that in terms of allowing certain services connect or not. Is that basically what you're trying to ask? Yeah, at this point the answer is no. So it's sort of all or nothing approach. I know that there's some teams looking at ways that we can actually correct this, but for now, if you add the address 0000 to your IP firewall rule, then it basically tells the database firewall that anything that comes from within Azure is allowed. So not ideal, but it gets around the fact that the IP addresses, like you said, can change very wildly. The other thing you can do also is if you have, especially if you're coming from external, from the internet, and you have dynamic IP, you can try to find out what the range of dynamic IPs that you have, and you can set that as an IP filter rule. Obviously not as good as having one particular IP. Yes? That's a very good question. So the question is whether you can add rules dynamically or you have to restart the service. And the answer is that it's dynamic. Okay? There's no real way for you to actually go and stop and start your service. Right? It's the database is up or it's not. And when you actually go to the management portal and try to add a new rule, it does, or is it documentation? They do give you a warning that says it may take up to 5 minutes for the rule to go into effect. But my experience so far has been that it's been almost instantaneous. Okay, so it's dynamic for sure. Is there another question? Okay, maybe someone's scratching. All right, so the next thing I want to talk about is DOS guard. Okay, this is basically a service that's inherent to Azure SQL DB, and again, this is something that we don't have with SQL Server, and it's directly attributed to the fact that we're a big service out on the internet that's getting pinged all the time and attacked all the time. But it provides some protection against denial of service attacks. And a denial of service attack is something that's actually very, very prevalent these days, especially when you hear the news around foreign governments trying to launch denial of service attacks, anonymous, everything else. Azure is a big target. And so what this does is it provides some mitigation against some sort of attacks. And what happens is that the service actually detects when there's a repeated number of bad connection attempts coming in. So, it detects bad connection requests, such as, someone repeatedly tries to connect with an invalid user or password, okay? And once it detects and sees that, hey, this is abnormal, it's a little bit too much, then it blocks that IP address at multiple levels. It could be at the database, the server, the service level for up to about 5 minutes, okay, before it releases it. So this is actually a way for it to actually prevent or at least kind of mitigate some of the denial of service attacks. And there's not a whole lot else that I can really say about this right now. It's something that we don't divulge publicly in terms of everything that around how this works, and this is for security reasons. But I will mention that this is not the only form of DOS prevention that we've implemented. There's also other internal efforts to try to prevent things like DDoS and everything else, and so we're continuously trying to make sure that the service is up and stable and secure. Okay, so but obviously for a service that's up on the internet, this is one of the big things that you do have to be concerned around. And there's nothing for you to be able to configure or for you to be able to control. But I just want to let you know that we do have something in place to help prevent some of these outages and attacks from a DOS perspective. Question?
Two questions. Number one, will this also block other Windows Azure Service IPs that are bad actors as well?
Mm-hmm.
And number two, I've had problems before occasionally about getting connections wrong. Does that trigger this as well?
Okay. They're good questions. The first question is whether this applies also to Windows Azure IPs, and it applies to all IPs. Okay, so if we detect that there's a particular IP address that's causing a lot of traffic, that's bad traffic, bad connections, then this will kick in. And then the second question you had was around throttling, and this is not related to throttling at all. Throttling is more of a load balancer type of behavior where they're trying to load balance and mitigate the risk of a machine getting really, really slow. No, throttling is a separate thing. Yes? I'm sorry? Right. Well, I mean, I think that there's a trade-off here between, like blocking for too long and actually blocking it all. And the 5 minutes was something that, a group of people did a study and found that, when someone's doing a DOS attack, typically what they do is that they're flooding the service with, sometimes hundreds or thousands of connection attempts, right, over a very, very short period of time. So, having them actually go and have to wait 5 minutes, and then when they do it again, they get blocked for another 5 minutes. So it's actually not that, it's 5 minutes and then they're free. It's 5 minutes and then they may potentially get blocked again. And so this actually does greatly reduce the number of attempts to actually go through the service. Okay. All right. The next topic that I want to discuss is actually protection within the service. Okay, so now that we've actually gone through all the network safeguards, we get through into the service, what happens, or what do we do to actually, keep things safe? So this diagram is just a very, very basic, block diagram that shows that, first of all, we come in through the internet. And once we, assuming that we don't get blocked by DOS guard and that we get, don't get blocked by the server firewall, then the front-end node, which is also the TDS gateway, Azure SQL DB being a massively distributed system, has several different types of machines that serve different purposes. And when you actually go and connect in, it actually goes in and has one front-end node or a bank of front-end nodes. I just represent as one machine that actually service your connection request. Okay, and in this front-end node, they do the authentication. So you come in, it'll go and take your credentials, and then use the virtual master to actually go and validate that, first of all, the password that you sent me matches a password hash that's in the master database. Okay, so authentication occurs right then. And then once I've validated that, hey, this person is authenticated and he is meant to be connecting to our service, then we'll do a lookup and find out, well, he wants to connect to database X or database 1. Where is database 1? And let's route him. And so then the front-end node serves the purpose of routing the connection to the proper back-end. Okay. Now, the one thing is that once you actually go and connect to the back-end, like for example, suppose this connection went to DB1, then once you get to DB1, what happens is that we actually go and create a context, a security context. In our terms, we create a user token. And that user token is crafted in such a way that's only valid in that database. Okay, it's not valid anywhere else. So if you were to be able to steal that token, which you can't, but if you did, and move it to a different database, it'd be completely invalid. Okay, it's only valid in that one place. And so this is quite different than SQL Server. In SQL Server, you had the case where, I had a user token, but I also had a login token. And that login token represented the proof that I've authenticated myself to the SQL Server service, and I have access to all the databases where I have users defined. That's not the case here. Okay, you don't really have a login token. You only have a user token, and that user token is sandboxed to that each database, and which is why it's a security boundary. Now, if you use SQL Azure, then you know that we already have it's a single database type of system. You can't go and use 4-part names and go and connect to the other databases or use. And if you try to move to the other database through a use statement, for example, then that's not going to work. It's not valid. Okay, so you really are locked to that database. So what I'm trying to say here is that we have security boundaries built into the system around each of the databases. Okay, between servers and between databases, and so it really, really does provide database isolation. Okay, more than it ever did in SQL Server. In SQL Server, there's lots of ways you can move the context from one database to another. There is a cross-database ownership chaining. There is also, there's a lot of things like that, but there's no such thing in SQL Azure. So this kind of rehash. The security context is isolated to the database. The generated context is invalid outside the authenticating database. And if you want to move to a different database, here comes the train again. If you want to move to a different database, then it does require you to actually go and re-authenticate. You have to go out and make a new connection to that second database if you want to go there. You can't do it from within the same session that you've already established. And you can't use a use command to get to another database unless you're using federations, okay, which is sort of a slightly different thing. It's a special case because in the case of federations, each of those databases are shards, and they're supposed to be part of one larger logical database, right? So when you use between shards in a federation, you're basically using between different parts of the same database, which is why it's allowed. Any questions? Okay. So next I want to talk a little bit about server principles. Okay. So there's a big difference between the server at Azure SQL DB and server in SQL Server. In Azure SQL DB, a server is nothing more than just a logical and administrative container for databases. In the SQL Server world, the server actually meant that you owned everything under there. It was not just a concept, but it was actually the object that encapsulated all the databases underneath it. Right? Azure SQL DB is a massively parallel system that's distributed where the databases can be all over the place. Okay? They're not on a single machine. They're definitely not in a single process. And so the server is just a concept that groups together databases that are owned by the same server admin. So that's one thing to actually keep in mind. The second thing is that the server admin, which in the books online, unfortunately, they call it the server level principle, which is dumb. It wasn't me. It's a pretty dumb thing, I think. But it's basically equivalent to your SA that you have in SQL Server. Okay, so this is a person that actually has full access to all the databases. Okay, they own everything. And just like SA, they can connect to any database even without having a user defined in there. And that's because, just like SA, when you connect in through there, they actually go and map you to a DBO. Okay, so highly privileged user. The other thing in SQL DB is that unlike in SQL Server where you have a lot of different server roles, and in fact, you actually even have flexible server roles. You can create your own roles at the server level if you want. There's only 2 fixed administrator roles, and those are the only things that you can use. And in fact, they're not even really server roles. They're database roles in master. Okay? One's called the DB manager, one's called the login manager. And the DB manager, obviously, it's for managing databases. You can create, alter, drop databases. The login manager, you guessed it, it's for create, alter, drop logins. Okay. The server admin implicitly has these 2 rights already, so they don't need to be added explicitly. But since these things are actually not real server roles, because like I said before, there's no true server, what these are that, if you want to add someone to these roles, you have to go to master, create a user for that login, and then add those users to the database. Okay. It's a little bit of a different kind of concept than it is on the box world. Like I said before, there's no server permissions or user-defined server roles. Those 2 roles are it. Okay, it's not, in my opinion, it's not the most ideal situation, but it is something that we have to address coming up. But for now, you're kind of restricted to, if you're not the server admin, you can either have someone manage your databases, manage your logins, but there's not much more granularity beyond that. On the database scope, and this isn't really a server thing, but I just want to call out that at the server level, I just described that we have a big difference in our permission model in terms of capabilities, what we offer. But at the database level, because the database is essentially the same as you're used to on SQL Server, you have all the same permissions, all 200 plus permissions and roles, and you can create your own roles, and you can do all sorts of stuff and deal with our very full-featured, which means complex permission model. So you get to do all that kind of stuff. So that's all still there. It's just at the server level that's different. One thing I want to call out is that normal logins can't change your own password by default. Okay, so you're probably used to the fact that I have a login, I want to change my password. Well, I can just do an alter login, give my name, password equals blah, old password equals blah, and then I change it, right? Well, that doesn't work, and the reason is that in order to, well, I'll talk about next. The reason is that in order to change the password of a login, you either have to be a login manager, okay, or you have to have a user created in MasterDB. Okay, so again, this is all going to the fact that there's no true concept of, it's not really the same server that you're used to in SQL Server. It's more of, like objects and principles within MasterDB itself. And so you can do one of these two things, but I don't recommend you do the second thing, okay? And the reason is that we have a problem, that any user in MasterDB will be able to see most of the database and catalog views. Okay? And it's because when they originally created the virtual master, and they, set the permissions and everything, I believe that the design assumption was that there wouldn't be very many users in master, and so they made most of the views open to public. So if you had access to master, then you had access to these views, and they made the assumption that you would be a privileged user at that point. But that's no longer the case, right? Because obviously, being able to change your own password, I believe, is something that people should be able to do. And these are the sort of views. I mean, there's a big list. You just have to look on the books online to see which ones they are. But there's some ones here that you probably don't want everyone to see, and things like, let's see, there's event log, there's sys.databases, sys database permissions, database principals, tables, firewall rules, database firewall rules. Now, you get the point, right? Some of them are kind of locked down. Like, for example, I tried this morning to do a query from sys.SQL logins, and that does get blocked. It does really do a check to make sure that you are a login manager. But a lot of these other ones are open to public, and so you have a security concern if you start creating users to master. Okay, and this is something that we're aware about, and I'm trying to get changed. Any questions around that? No? Okay. So I want to kind of finally talk about some of the other security differences. So I mentioned some of the main differences between SQL Server and SQL Azure, and some of the key things that SQL Azure does. But there are actually a bunch more. And I'm going to go enumerate through all the ones that at least I can think of. Some of them I've already mentioned, but a lot of them I haven't. And the first one is around authentication. So everyone's probably already noticed the fact that you can only do SQL authentication, user ID and password based, right? And there's no Windows authentication in Azure SQL DB. And so that's the case right now. Doing Windows authentication to the cloud is surprisingly harder than you would think it would be. But all I'll say right now is that that's the way it is at this point, and it is something that we're looking at. Fixed password policy. Okay, so when you try to create a password for a login in Azure SQL DB, if you try to do something like ABC123, it's going to say this isn't complex enough. Okay, and it's because there is a fixed password policy. I think it's 8 characters, and probably you need mix of lowercase, uppercase, and numeric, or something like that. But people who are coming from the SQL Server world, have it a little bit better, because I can define the password policy at my domain, and I can get that pushed down into SQL Server as well. And so even when I create logins in SQL Server, it will obey the password policy set forth by the Windows group policy, which is great, right? Because now I can unify all the password policies. But that's not the case for Azure SQL DB. Idle connection timeout. This is actually a very, very good feature, okay, that we don't have in SQL Server. So basically, if you have a connection that's open and you leave it idle for 30 minutes, then the service will actually terminate that connection automatically. Okay, so yes. So the question is, can you configure that lower? And the answer is no. That's fixed at this point. But we could talk afterwards. But right now, the value is 30 minutes, and after 30 minutes, it will disconnect. So this prevents the situation where you have someone who just leaves their window open, connects, and basically leaves the service exposed. It's all about leaving the service exposed, and so we try to mitigate or reduce the impact of that. No native encryption, data encryption at rest. Okay, so there's no TD and cell-level encryption at this point. Again, something that we're looking at, but at this point right now, if you are going to use encryption with the cloud service, you need to do the encryption at the application level or ahead of time before you send it up there. Okay. And in any case, some people would do that regardless of what we provide because they want to make sure that they achieve the maximum separation between the cloud operator and their data. So as long as the cloud operator doesn't have keys, they can never see your data, right, even if the data is stolen. So that's kind of thinking. Auditing. In Azure SQL DB, the auditing has to be performed by the application, or you can set up a series of triggers to trigger some of the DML, DDL. Okay, which is unlike SQL Server, which has their own auditing feature that allows you to audit all actions at both the server and the database level. Okay. Now, there's a few more differences I want to go through. So we talked about the database firewall. Great feature, SQL Azure only. SQL Server, you could do something similar by using login triggers. It's obviously more work. It's not as easy. It catches the request at a different level in the stack than it does in the firewall. The firewall actually catches it very early. So, but you could craft something similar on SQL Server if you wanted to. DOS Guard, Azure SQL DB only, no native DOS Guard in SQL Server. You could potentially do something like with login triggers again, but it would be quite a bit of work because you would have to try to keep track of all the IP addresses and activity and stuff. So it's definitely not trivial. The virtual master DB with virtual logins, okay, and then you have master DB with login principles. So we discussed this already. The fixed roles in master DB, and then as opposed to user-defined server roles and server-level permissions, we discussed. And then the automatic patching with no downtime. This is a big thing, right? I mean, if you've run your own SQL Server instance before, you know that every time there's a patch, you have to schedule some downtime, unless you're using some of the Hadron features, always-on features, excuse me. And you have to, do the patching yourself and everything. Well, in the Azure SQL DB service, and this is one of the big value adds, is that not only do we actually maintain several copies and give you 3 nines of HA high availability guarantees, but we'll make sure that the code is always patched and patched with anything urgent right away or as soon as possible, with no downtime to your application. Okay, so this is a really big thing. It means that you can not have to worry about always having the latest security patches in place with your code, with our service, and so don't dismiss that as something that's really, really useful. Question? Is
there any kind of notification when a patch is applied to the database?
The question.
Production operations where a patch is applied which breaks the database.
The question is that if there's any kind of notification when a patch is being applied, and I'm not 100% certain about that. I think the answer is no, but if you drop by afterwards, I'll get confirmation on that. But I believe the answer is no, that the system takes care of it automatically under the covers. Okay. Any other questions? All right. So I'm going to try something here where I'm just going to play around with the computer, and hopefully things don't break. I was having problems with the internet this morning, so hopefully things are back on track. And if you guys, this will be more useful for people who haven't used the service yet because you get to see how things are. If you've used the service before, then this may not be as useful, but we'll give it a try. So the first thing I want to do is I want to show you what the portal looks like. Okay. So can everyone see? Okay, let me speak up if you guys can't see, and I'll try to increase the font size. But I have a subscription here, and it's got 3 different servers defined, and they're all online right now. So what I want to do is that, I'm going to just go and I already create these services ahead of time because I didn't want to take the time in case, it took a long time to generate. But, I'm going to just go and create a new service here. Hold on. Let me go back. Okay. Let me go here, and then I'll manage. Okay. So notice at the bottom right now, it does a really nice thing. It detects what my IP address is coming into the service and says that I don't have a firewall rule for this. Do I want to set one up? Okay. And so again, this is a new service I just created this morning. So the firewall is completely closed to everyone, and it recognizes the fact that in order for me to connect, I'm going to have to go and at least open up one IP address. And so I'm going to say yes, and it goes through and it adds it. And so, do you want to manage the test service 2 now? And I say yes. And then it brings me, it should bring me eventually. By the way, this is the first time I'm doing a demo with over the internet. I've always been really scared of doing this because I've seen some really bad situations. But if it goes bad, then I'll probably not do this again. Okay. So I'm connecting to my service right now through the management portal, and I'm going to log on. So it's taking a little bit of time. Come on. So what it's doing in the background right now is that it's going through the Azure portal. And so the SQL, Azure SQL DB is just a small portion of the Azure portal, right? And so we're going through the same framework that all the Azure customers do. And then when we go and manage the SQL service, then it goes through our portion of the Silverlight code. And so you can see it here. Okay. So let's see. Overview, databases. There was one place where I remember seeing something around import, export. Just give me one sec. Okay. So there was one place here where I should have been able to see the firewall rules. I can't remember where that is. Let me go back. It's in the management port, right? Okay, let me go back. Yeah. Manage server. There we go. It's not there. Let me try that one more time. They changed this portal a bit since the last time I used it, so you have to forgive me a bit. Where is it configured? Oh, there we go. Thank you. Okay, so here right now you'll see that this is a server level firewall. Okay, so when I clicked on yes, you saw that this is the second entry right there that added my client IP address to this rule. Okay, and so now I should be able to, and here you can also say that I want to allow the Windows Azure services. And if you do this, it adds to this rule the IP address 0000, which is a special IP address that symbolizes Windows Azure. Okay. So now that I've opened up the port to myself, I should be able to connect, right? And I can do things like, dashboard, databases. Here we go. You'll see that they do some nice things here. Like, for example, I can see what my server name is. And you can see the history, everything else in here. So there was one place here also that they actually showed us the connection string. Where was it? Let me play around with this a bit. Oh, in any case. So I'm going to go to Management Studio now. I'm going to connect and enter my password. And remember what I told you about making sure that you set the encryption turned on for for your clients. But you can do that through SSMS as well. Just make sure that checkbox is checked. And so what will happen now is that my client will validate the server cert. And if it turns out to be an invalid cert, then it'll throw an error and it'll disconnect. So just remember to set that on. Unfortunately, it's not set by default. So the question is that if I don't set that, it won't validate the certificate, but it will still establish SSL. That's absolutely correct. So by not setting that, what's happening is that the server is forcing the client to use SSL. But the client's logic is that, well, I didn't actually request it, so I don't care where the certificate came from. But if the client says that I want to do SSL, then it means explicitly I do care about using encryption. I do care about where the certificate came from. So that's why you should turn it on. Okay. So now that I'm connected, you'll see here that this kind of looks the same, except that all the administration, the security administration at least, is not really done through It's not really done through this panel here where you have the logins. I mean, that still shows up. But a lot of it is actually done through master. Okay, so you'll see things here like the tables, views, everything security here. Now, what I'm going to do is that I'm going to create a user. And so just to make sure I know who I am, okay, so I'm me. Okay, I'm logged in as a server admin, and I'm in master right now. And unlike in SQL Server, to issue a lot of these, create logins, create database commands, everything else, you have to be in master. Okay, in SQL Server, you were able to do things from user databases in a lot of cases. Here, you have to explicitly connect to master. You can't be in a user database to do this. And so here, I'm going to go and create a login. It's not complex enough. Let's try this. Let's try. Okay, so I create a user test now, right? And if I look in the system views, system tables here, you'll see that where is it? Test service. Refresh. It's not showing up yet. If I do a select star from sys.sql logins, you'll see that the test exists down there. Okay. Am I on a different server? You're right. Thank you very much. So there we go, right there. Okay, so before you were able to query the sys server principals, but in SQL Azure, you have to use the SQL logins, okay? Because there is no Windows principals, it's just SQL logins. And then the other things I can do is that I can do things like, select star from sys.firewall rules, right? And then you'll see all the firewall rules I've defined. The same thing that we saw in the portal. If I want to see what's set for the database, and the database in this case is master, obviously, I can do from sys.database firewall rules. And I don't have anything set right there. Now, if I did want to have actually something created for the firewall rules, I could do something like this, and I've actually kind of shortcut this. I could do something like here, which is calling this spec proc. So SP set database firewall rules, and you give it a name, then you give it the beginning and the end range. And if I do that, then if I do another query against sys.database firewall rules, you'll see that it exists there. And if I want to erase it, it's simple. I use the exact same. I use a different SP, but I just say that delete firewall rule instead of set firewall rule. So I do that, and if I query this again, it's gone. Okay. A question? Sure.
The master database will always have to have every rule allowed for any specific database, correct? For both the logins and process?
So the question is if the master database has to have every single rule allowed in order to. Yes, kind of. Okay, so remember the master database is it's another database. Okay, so I can create a user and give them access to database 1, but not give them access to master. And if I set up a server level firewall rule that says allow the IP address from that customer to come in, then he'll be able to get through into the database 1, but not into master. So the server level firewall kind of covers everything. It's a higher level of abstraction than the actual individual database firewall rules. Okay. I can have a server level rule that says allow this person to come in from that IP address to this database, or just allow this person to come in. Then he'll be able to come into any database in the server, including master. But if I decide that I'm not going to allow his IP address to come in at the server level, but I only enable for one particular database, then he'll only be able to connect to that one particular database, not to master. It will not block the login. It's blocking direct connections to master. Okay. So it's as simple as that. Now, the only other thing that I really want to kind of show you guys is that, remember that thing I told you about the change password? Okay, so I want to kind of show you, the consequences of doing that. So what I will do is that I will, first of all, have to remember what the password was. It's my password, 1, 2, 3, 4, 5, 6, 7. And I'm going to go and connect here. Options, remember turn on the encryption, and then connect. Whoops. Let me try that again. Can't connect to Windows. Did I say type in the right password? My password, 1, 2, 3, 4, 5, 6, 7. Let's try that again. So I'm going to connect. That's right, test, and then options, encrypt connection, and connect. Can I open master database requested by login? The login failed. Oh, you know why? My bad. So this is exactly, inadvertently I showed you exactly what I told you about before. I haven't given him access to master, right? So if I create a user at master, then you'll see it. So what I need to do over here again, oops. What I need to do over here again is I need to do a create user. Create user test from login test. Okay, so now we have a login called test, right? And now if I go back here, and let me try to park this thing back here, and I connect, then that should work. The alternative thing I could have done is I could have just created another database and given him access to that database, right? But, oops. And set the encryption connection, connect, and now he's in, okay? So now that he's in right now, I haven't given him any particular access. You didn't see me add him to any particular role. He was just a normal user. But, the dangerous thing is that, even though now he may be able to change his password, because remember what I told you, the create, alter, drop, login commands only work if you're a master, that the consequence of that is that, if I go and, select myself just to prove to you that, whoops, I guess it's already had a connection here. If I prove to you here that, I am test, okay, and I am in master right now, okay, so exactly what I said. If I try to do a select from any of these tables, I'm actually getting data back, right? In this case here, I'm seeing all the principals defined in this database. Or, the sys.logins, as I mentioned before, that does seem to block it. Okay, it tells me that I don't have access. That's because I'm not a login manager. But I can do things like, I can see the firewall rules now. Okay. Now, it doesn't mean I can change it, but it does mean that I can actually see data that I potentially shouldn't. Or even things like, sys.databases, which, not all people would want people to know exactly what databases exist on the system. But myself, as just a normal user now, is able to actually go and see a lot of these different, sensitive metadata that you probably don't want to be exposed to public. So, this is why I'm saying that, you probably don't want to create users in master for people who are not administrators until, we can do something about this. Any questions on that? All right. So I'm just going to wrap up now. Just to conclude, just to kind of rehash some of the stuff that we talked about here. So first of all, if I haven't stressed enough, configure your client applications to validate the server certificate. Okay, there's a lot of good that does there, and it actually doesn't change any of the performance or anything else from your application's perspective. It's already doing SSL encryption, but without setting the encrypt on the client, you're not actually validating the server cert. So please do so. Use the most restrictive firewall rules settings as possible. It does you no good if you decide to open up the firewall to all the IP addresses out there, because you might as well not have a firewall in that case. So use a firewall, have a very, very restrictive range of IPs, and if possible, limit to the database itself, so that even if someone does attack a particular database, they'll be blocked from attacking the other databases. It's not always possible, but if you can, you should. Minimize the number of users in the admin roles. This is kind of a general statement around security for everything. You should try to do the principle of least privilege. Not everyone needs to be admin, and carefully control who is. I admit that we don't have a lot of granularity in this case, but for now you should try to be very careful. And as I just showed, avoid creating users in master. Okay, it's exposing a lot of data to people that don't necessarily need it. And lastly, what I want to mention is watch for future enhancements. Okay, so we take the security of the service very, very seriously, and we're continuing to try and improve it. A lot of the things that you see, a lot of the things that we do may not be something that you necessarily see, maybe something that we do behind the covers. As I said before, we may be doing infrastructure work or doing things to help prevent distributed denial of service attacks. But watch for news to come in the near future. I think that this year will be a very interesting year for security and Azure SQL DB. And with that, I'm doing the final mandatory slides, I guess. I'll be at the Data Insights booths from 12:15 to 2:30 if anyone does want to come talk to me. And I'll also be in the booths Wednesday and Thursday mornings as well, in case you want to see the same Data Insights booths. And then the rest of these are just regular resources and stuff that I'm supposed to go through, or else they don't invite me back. All right, with that said, and please complete your evaluation. Not only do you get some free, potentially get some cool stuff, but it's good for us to know, whether the content was useful or not, and I do appreciate the honest feedback. So with that said, thank you very much. If you have any questions, I'll stick around for a little bit longer, but thank you.